Okay, this question is from exercise 2E of the Oxford textbook. And I think what we're trying to do here is we're just trying to find things like domain and range here. So looking at this really quickly, first off, we have to recognize that this is kind of a weird function. First off, it's rational. So it's rational, so that means that the denominator can never equal zero. But the other deal with this is that it has a radical in it, hence the value under the radicand cannot, it always has to be bigger than zero. Okay? So that's going to come into play later on. What I'm going to suggest is what we're going to do to start this is let's look at that radicand and let us try to factor it as much as possible because we need to know where this thing is or where this thing is zero, where it's below zero. So if I look at this, I'm going to have to split the middle term. So two numbers that when I multiply them together, they equal -4, but when I add them, they equal -3. Those two numbers would be 4 and 1, specifically -4 and 1x. And then I've got 2x squared. So I've got my split. Now I just need to factor this thing. So that'd be 2x times x minus 2, and then plus 1 x minus 2. Those match, so I'm pretty good. So I get 2x plus 1 and x minus 2. So that is the location where these two would equal 0. So that means right away we should be able to recognize that when x equals -1/2 or when x equals 2, these are going to be asymptotes. Okay, so we've got something strange going on here where I'm just going to sketch in x equals -1/2 and x equals 2. It's right here. Okay, so something's going on with this particular function. We've got our things there. Well, first and foremost, because it's a radical expression and there's no negation here, it means that I'm always going to be positive. So what's going to happen is this function is either going to be always positive and look something like that. I guess it's possible that we have something where it's always positive and looks something like that. But those are our two boundaries that we know it can't be. What we have to find out is what the heck is happening in the three regions that we've just found. What's going on here, what's going on here, and what's going on here. So all I'm going to do is I'm going to just do some substitution and kind of treat this like a sign diagram. So if I substitute in -1, what do I get from this? Well, if I do 1 divided by the square root of 2 times -1 squared minus 3 times -1 and minus 2. Well, if I do that, that turns into, that's 2, that's plus 3, that's minus 2. So this is 1 over the square root of 3. It's positive, so we know that this thing is going to be positive looking something like that just before. Now, if I try something in between here, I'm going to do 0, just because I'm super lazy. Well, if I do 0, I get 1 over the square root of 2 times 0 squared minus 3 times 0 minus 2. Will that be 1 over the square root of negative 2? That's a non-real solution. So what that means is, in between these two asymptotes, it doesn't exist. So there's nothing in there. And then if I look afterwards, let's put 3 in. So this is, if I put 3 in, I would do 1 over the square root of 2 times 3 squared minus 3 times 3 minus 2. Well, this is 1 over the square root of 18 minus 9 minus 2. So that'd be 1 over the square root of 7. I mean, that's an ugly number, but that definitely is something that exists, and it's positive. So what we have going on here is we have actually this situation here, where because of the fact that it's a radical, and because in between these poles we get non-real solutions, our function looks like that. So our function is always going to be positive because it's a radical. The function is basically undefined between negative 1/2 and 2. So we would say something like our domain, I don't remember what this question's actually asking me. So the domain is x such that x is less than negative 1/2 in union with x is greater than 2, and x is an element of the reals, and then our range is going to be y such that y is greater than 0, and then y is an element of the reals. I hope that makes sense. I hope that that's clear enough. Good luck, guys.